In Chapter 2, we're going to work on organizing and summarizing data. In other words, making a lot of tables and charts and graphs. That's what we're going to work on. All right, Section 2.1, we're going to look at organizing qualitative data. Now remember from Chapter 1, if you've watched those notes, qualitative data are data that are words or categories, right? Not numbers, or if they are numbers, they're numbers that cannot do meaningful calculations. Okay, so we need to learn a few definitions. A frequency distribution, we will talk about distributions a lot in this course. Those are tables, charts, or graphs that list each possible value of a variable along with the corresponding frequency or number of that value. Frequency can be written several ways. Number is one of them. Count is another one. How many, or that kind of thing. So I'll just put dot, dot, dot there because it could be several different terms. The most frequent ones are frequency and number. Now, relative frequency is the proportion of observations that occur within a category. Now, proportions are when you take the number that's in the category and you divide by the total. That creates a proportion. Now, proportions can be written several ways that are useful for us. We can write them as fractions, very similar to what you see right here, where you take the number and divide it by the total. They can be written as decimals, and they can be written as percents. Percents are really just decimals written a different way. The most common of these for us by far will be decimals. Decimals will be the one that we are going to use most of the time. All right, and then a relative frequency distribution is a table or chart that lists each possible value with its relative frequency value, not just its frequency. So frequency up here for a frequency distribution, relative frequency for a relative frequency distribution. Okay, so let's look at this example. This is a survey that I gave to Math 133 students, a small class of Math 133 students, and they were asked, how do you consume the books you read for pleasure? And their answers are shown in the frequency distribution below. Now, it's a frequency distribution because it has the categories and their corresponding frequencies. All right, so first thing, it has this little symbol right here. That's actually the Greek capital sigma, right? Sigma. It's capital sigma. It's actually the larger of the two sigmas. We will run into the lower one later, right? So capital sigma, it means to sum. It means the S, sum, right? It means to find the total. All right, so we are going to find the total of these. So we're going to add. So 13 plus 6, right, makes 23. Right, 13 plus 6 plus 3 plus 1 is 23. I could, of course, check myself really quickly in Desmos. Desmos does our adding and subtracting for us. There we go. So it is, in fact, 23, just like I thought. Okay, so I know that the total is 23. Now I want the relative frequency. All right, well, the relative frequency, and it says right here we want to have 3 decimal places. So that implies that we want decimals. Okay, so let's take 13 and divide it by 23 and find what that is. Then 6 will be divided by 23, 3 divided by 23, and 1 divided by 23. Now those are the fractions, and then we're going to round it to 3 decimal places. I will say that when I say give in the course pack, I always mean rounding. We do rounding because we are a math class. So actually, let me make a note that it's rounded decimals, right? It's always rounded for this course. Okay, so I will go grab Desmos, our calculator, and I'll ask it what 13 divided by 23 is, 6 divided by 23, 3 divided by 23, and 1 divided by 23. And I have all of those decimals. I will round them to 3 decimal places. So the first one would be 0.565, 0.565. The 0 is not actually required, but it's very nice to use it because Otherwise, you can lose track of where your decimal point is. So I used to not write it as a student, but I've learned as an instructor to start writing it all the time because otherwise it's too easy to lose the decimal point and think it's a number, a whole number rather than a decimal. All right, now the 8 would round the 0 up. So this next one would be 0.261 because 8's a high number, right? You go to the fourth decimal and you look. So 0.261 for the second one. 0.130. The next number is a 4, so we're actually going to stay with the 0. So 0.130 and then 0.043, right? The next number is a 4. Anything 4 and lower, you allow it to stand. 0.043. All right, so now we want to add those because we're adding not only the frequencies, but just to check ourselves, we're going to add the total here as well and find what it is. So the sum of these decimal points. So let me go grab Desmos real quick. 0.565 plus 0.261 plus 0.130. Oops, and I made a mistake right there. Look, see that? There we go. 130. Now notice this didn't add up to 1. But it should, right? Because we have 100% of the values covered. So what's happening is because we've rounded each of these to 3 decimal places, we can lose a little bit of accuracy here. This is called rounding error, if you've ever heard of that in science class. So when we add these up, we get 0.999, but we all know that's really 1. Right? What's happening is the third decimal place is where we rounded. And so because some of these went up and some of them did not, we ended up with a 999 situation. That's okay, that happens, right? This is rounding error. So nothing to freak out about. If you're only off in that same decimal place that you added them up and you're only off by a tiny, tiny bit, that's okay. Okay, so then how many students were in the sample? Give the symbol. Okay, so this was a sample. Notice this wasn't all the students for Math 133, it was a sample. And so how many students is the size? So we're asking how many. That's sample size. Sample size we learned in section 1.1 is little n. So little n was 23. There were 23 students in this sample. All right, how many students chose an e-reader or a physical book? Now, or is an interesting thing in statistics class. In statistics class, or will mean to add. So we want to know how many students were e-reader or physical book, and how many means it's frequency. This is a whole number, not a decimal. So we're going to take the e-readers and the physical books. So e-reader is 6 and physical books is 13. So 6 plus 13 makes 19 total. What percent of students chose an e-reader or physical book? That's a different question. So this is saying percent. So that's really a relative frequency question. All right, so if I take e-reader or physical book together, I would add up these two. So 0.7, or excuse me, 565 plus 0.261. Or if you will, it's 6 and 13, or excuse me, yeah, 6 and 13 added up 19 divided by the total. So if I took 19 and divided it by 23, that would also work. Right? Or you could add up 565 and 261. So let's see how this works. So I'm going to go to grab Desmos real quick. I'm going to turn off these other ones just so we don't need to see them. Okay, so 19 divided by 23 looks like this. And if I take 0.565 plus 0.261, right, same answer. Now it's possible sometimes that this second answer will be slightly off because of rounding error, but in this case it was not. They were both the same. So it doesn't matter which way you do it. Either add up the frequency and then divide by the total, or add up the two relative frequencies. Either way, you should get 0.826. Now the trick is 0.826 is not a percent. 0.826 is a relative frequency, it's a decimal. But to make it a percent, we have to move the decimal 2 spots over. Percent is in the hundredths place, right? So we take the decimal point where it was and we move it 1, 2 spots over. Always 2 spots over to make a percent, because cent is 100. hundredths place, tenths place, hundredths place. So it becomes 82.6%. And that actually answers the question because it's a percent, not a decimal. All right, so let's do the same thing again. What percent of students chose to listen on Audible? All right, listening on Audible was 3 out of 23, which was 0.130. Okay, so we know this is 0.130, so we move the decimal one spot, two spots, because again, they want a percent, and we're going to make this 13%. Percents and decimals are very closely related, but they're not quite the same thing. Percents are actually more how we speak about numbers. They're not really what we use for mathematical formulas as a general rule, with one exception in this course. But as a general rule, decimals are more what we use for the actual math part, right? When we do the table, we come up with the decimals. And then if they ask for a percent on top of it, we just move the decimal two spots over, in this case to the right, to form, to go from a decimal to a percent. Well, I guess I should say move decimal. So we move the decimal two spots over. Right, to go from a decimal to percent, that's how you do it. And of course, to go from a percent to decimal, it would reverse the process.